This is Vicky Gaines. It's Introduction to Matrices. Let's learn something new. What is a matrix? A matrix is a rectangular array of variables or constants in rows or columns, both, usually enclosed in brackets. Here's one. Matrices are named using a capital letter, so that is matrix M. And we'll find out more about everything that goes into a matrix in just a minute. What are elements? Elements are the individual values within the matrix. Element A sub xy, so this is location, is used to denote each element, where x is the row number, okay? And y is the column number where the element is located. So here's the little matrix A, and they are labeled with where they are located. So right there is A sub 1, 1, that's row 1, column 1. That's A sub 1, 2, row 1, column 2. A sub 2, 1, row 2, column 1, and A sub 2, 2, row 2, column 2. So directions for an example here. Given matrix K down there to the left, find the value of each element. So we're looking for K sub 2, 3. So that is row 2, column 3. That's going to give us 31. Number 2, K sub 3, 1. So that is row 3, column 1, and that's 0. Look at matrix K. We want to know what K sub 1, 2 is. So that's row 1, column 2. That's 21. K sub 3, 4, row 3, column 4, 35. Number 5, K sub 1, 4, row 1, column 4, negative 2. K sub 2, 2, row 2, column 2, number 7. Those are the elements in each of those locations. Dimensions. A matrix with m rows and n columns is said to be an m by n matrix. Directions. Give the dimensions of each matrix. So look at here, 1 row, but there's 3 columns. So it's a 1 by 3. Next one, 4 rows, 2 columns. It's a 4 by 2. Next one, 3 rows, 4 columns. It's a 3 by 4. And number 10, 2 rows. Count them, 1, 2, 3, 4, 5, 6 columns. That's a 2 by 6 matrix. What are equal matrices? 2 matrices in which each element in one matrix is equal to the corresponding element in the other matrix. So I have a pair of equal matrices there to the left. Now we have some special matrices. A row matrix is just 1 row of values. Column matrix, of course, now is going to be 1 column. Square matrix has equal number of rows and columns. That is a 3 by 3. You could have a 2 by 2. You could do a lot of different things. It doesn't have to be a 3 by 3, but the rows, number of rows, number of columns has to be the same. Zero matrix. All elements are 0. Doesn't have to be a square. That's a 3 by 3, but it doesn't have to be that size. And a unit matrix, look at that. That's a square matrix. It has to be square with 1s on the left to right downward diagonal. So look up at our example there. And zeros everywhere else. That is the unit matrix. Matrices can be added or subtracted. So we're doing addition and subtraction, if and only if, two-way implication. They have the same dimensions. Simply add or subtract corresponding elements. So elements in the same location. So let's look at B. That is a 2 by 3, and C is a 2 by 3. So we can add those two together by adding elements in corresponding positions. So they are both 2 by 3. So our answer is going to be a 2 by 3. Let's put the calculations in. So element 1, 1 in both of those, 24 plus a negative 15, or 24 minus 15. Next one, negative 8 plus 29. Negative 3 plus 17. Negative 4 plus 9. 6 plus negative 5. And negative 17 plus a negative 2. So let's simplify these answers. We're going to get 9, 21, 14, 5, 1, and negative 19. Let's do D minus A. That is number 12. D is a 3 by 2. A is a 3 by 2. So we can do it. They are both 3 by 2s. Let's do our calculations. So we're doing D minus A. So negative 3 minus negative 1. Negative 2 minus 9. Negative 16 minus negative 11. 0 minus 15. 12 minus 8, and 9 minus negative 20. Let's calculate those to get our answer. Negative 3 minus negative 1 is negative 2. Negative 2 minus 9 is negative 11. Negative 16 minus negative 11 is negative 5. 0 minus 15, negative 15. 12 minus 8 is 4. And 9 minus negative 20 is 29. Same matrices. Let's do a couple other ones. 13, we have B. And we're adding A. Here's B, here's A. Can't do it. One's a 2 by 3 and one's a 3 by 2, so that is not possible or undefined. B minus C. Let's look at it. Here's B, here's C. So they're both 2 by 3, so we can do it. Our answer is going to be a 2 by 3. So B minus C. 24 minus negative 15, negative 8 minus 29, negative 3 minus 17, negative 4 minus 9, 6 minus negative 5, and negative 7 minus negative 2. Let's calculate those. 24 minus negative 15 is 39. Negative 8 minus 29 is negative 37. Negative 3 minus 17 is negative 20. Negative 4 minus 9 is negative 13. 6 minus negative 5 is 11. And negative 17 minus negative 2 is negative 15. Desmos. We're going to go to Desmos, and if you go to Math Tools, they have an option, it's down a ways, called Matrix Calculator. So we're going to put in the matrices A, B, C, D, just like the matrices we used before. So we're going to have to put in the dimensions, and the first one's a 3 by 2. So there's A. We're going to type those in. It will give us the A for the name, and it just goes in alphabetical order. So we're going to type in the values, and if we just do -1 and then right arrow 9, we can keep doing right arrow -11, right arrow 15. We can get all those values in, and then we're going to do another new matrix, and this time we're going to have to switch the dimensions. This is a 2 by 3, and put in all your elements. Same thing for C and same thing for D. So there's the new matrix names, A through H. So if you have other names on matrices, just keep it straight what your name is going to be if you're putting it in the matrix calculator on Desmos.com. B plus C, boom, there it is. So we don't have to type in the matrices to add them. We type in all the matrices, and then we just select where it says matrix. We select B, and then put a plus, and then select C. D minus A, real easy. A plus C, can't do it, and that's their symbol for can't do it, is undefined. A is a 3 by 2 and C is a 2 by 3, so you can't do it. B minus C, just type that in and you get your answer. What is scalar multiplication? Matrices can be multiplied by a constant, so a number. It's called a scalar. In this process called scalar multiplication, each element in the matrix is multiplied by the scalar to produce the new matrix. So there's matrix A, and we're going to find 3A. So to do 3A, and that's how you can write it, just with the 3 out front, we multiply every single element by 3. So 3 times 1, 3 times 6, 3 times 3, 3 times 7, 3 times -2, 3 times 1, 3 times 0, 3 times 8, and 3 times -9. To get our answer, we just need to write down what we got. So 3, 18, 9, 21, -6, 3, 0, 24, and -27. More scalar multiplication. So we have our same matrices, and we need to find 4A. So we need to multiply every single term inside of A, each element, by 4. And we're going to get -4, 36, -44, 60, 32, and -80. And now we're going to do 1/3 B. And we can use Desmos to check. Let's check the 4A, sorry. So we had our A in already because all those matrices are the same as the A, B, C, D that we used before. You can just type in 4A and boom, there it is. 1/3 B, so we're going to do 1/3 of each of the elements in B. So 1/3 of 24, 1/3 of -8, 1/3 of -3, 1/3 of -4, 1/3 of 6, and 1/3 of -17. Don't worry if you get a fraction, no big deal. 8, -8/3, -1, -4/3, 2, and -17/3. And if we put that one in Desmos and we do 1/3 B, they're not automatically going to come up as fractions, but right next to the matrix that has the decimals is an option. I mean, right to its right. That'll change it to fractions. Scalar multiplication and more. Same matrices, A, B, C, D. So you have them in Desmos. I'm going to show you the calculating now. So we're going to have to do double our C. So let's do that. Let's double each of those. So 2 times negative 15, 2 times 29, 2 times 17, 2 times 9, 2 times negative 5, and 2 times negative 2. And then we're subtracting b. And there's all the elements in b. I'm going to write a matrix that represents the 2c minus b, just all the calculations that you would need to do for each element to get our answer. So our answer is going to be a 2 by 3. So 2 times negative 15, that's the element in 2c, minus the 24, because we're subtracting b. 2 times 29 minus the negative 8, which is the same as plus 8. 2 times 17 minus the negative 3, which is the same as plus 3. 2 times 9 minus the negative 4, which is the same as plus 4. 2 times negative 5 minus 6. And 2 times negative 2 minus a negative 17, which is the same as plus 17. Okay, let's do our calculations for each one. And you'll get a negative 54, a 66, 37, 22, negative 16, and 13. Put it into Desmos.com or go to Desmos.com, the matrix calculator. You can just type in 2c minus b and we get all of our answers. And notice they are the same as when we calculated them. Hooray! We are now finished with Introduction of Matrices.